Okay, this video is for lesson 8.4 multi-step equation word problems. This is part 2 of the word problems video. So we're going to start in this video with a slightly different type of word problem than in the last video. These ones tend to be a bit trickier, so I'm going to give you some strategies for helping with these types and these two examples that we're going to do today together. So in this question it says Mary is 6 years older than her sister Kelly. The sum of their ages is 48. How old are both Mary and Kelly? So this one is tricky because we actually have two missing pieces of information. We don't know how old either of them are. And so what happens when we try to write our let statement is we actually need two of them. We can't use two different variables though. We have to use one variable, and that can be really tricky. So the first thing you want to do is figure out who we want the variable to represent. So in this problem, since it's referring to Mary's age in terms of Kelly's age, it's saying Mary is 6 years older than Kelly. We would need to know Kelly's age first and then add 6 years to find Mary's age would be the way that this problem is worded since it says older than. So I would write let K equal Kelly's age. Now, you can do it the opposite way and let the variable represent Mary, but I'm going to do it as K is Kelly. And like I said, that's because it says in the problem that Mary is 6 years older than Kelly. So that means we need to know Kelly's age first, and then we'll add 6. So then what we're going to do is we're going to write another let statement to represent Mary's age. We can't use a new variable, so we're going to write an expression based on what the problem says for Mary. So it's Mary is 6 years older than Kelly, so that's K plus 6 is Mary's age. So we're using the same variable. We're using K for Kelly, but we're taking Kelly's age and adding 6, and that represents Mary's age. So for our equation, it says the sum of their ages is 48. So that means we have Kelly's age plus Mary's age equals 48. What we can fill in on those blanks are the two variables expressions that we wrote above. So K is Kelly, K plus 6 is Mary. We have to make sure we include both of them. Kelly by herself is K, and Mary is Kelly's age plus 6. Now when we go to solve it, the solving is not super difficult. It's the writing that's hard. K plus K is 2K plus 6 equals 48. Subtract 6 from both sides. We get 2K equals 42. And then when we divide by 2, we get K equals 21. So for our final answer, we have that Kelly is 21 and Mary is 27. Okay, before we try the third example in your notes, we are going to try to identify the equations for these two word problems first. So give these a try. So for this first one, we need to write a let statement. We're going to say let J equal Jill, and then we're going to write another one that says J minus 4 equals Jack. Now I did it this way because that's the way it's worded in the problem, that Jack is 4 pounds less than Jill. So that would be Jill minus 4. Again, you can reverse this. You could say J is Jack and then Jill is J plus 4. I just like to do it the way it's worded in the problem so that it's more of a direct translation. And then it says together they carry 20 pounds of water. So the equation is J plus J minus 4 equals 20. For the second example, we know that there's a total of 970 students at Hampton High School. It says some ride the bus and the rest arrive by car. The number riding the bus is 1/4 of the number arriving by car. how many students arrive by each. So we know that we're going to say let C equal the number of students that arrive by car. And then since the problem tells us that a fourth of those ride the bus, then we're going to say let C divided by 4 equal the number of students by bus. You could write that as C divided by 4. You could write it as 1/4 C, or you could write it as 0.25 C if you like decimals better than fractions. Same as the one above, you could actually define your first variable as the number of students arriving by bus, and then that would mean that the students arriving by car, instead of 1/4, would be times 4. So that would be like B times 4 if you're using B for bus. So you can reverse all of these. Again, I just like to do a direct translation from the word problem, and I think that makes it easier rather than trying to think backwards. So the one that I wrote for this is C plus C divided by 4 equals 970. I would say this one is probably easier to write it as 1/4, because then when you do 1C plus 1/4 C, you get 1 and 1/4. Actually, a decimal would be the easiest. If you did 1.25, that would be fine. Okay, let's try this one. Also, choosing the equation that would work for this problem. This one is a little bit harder because there are 3 people in this problem instead of just 2. So we have Stephen, Caitlin, and Austin compared the number of Snapchats they each received yesterday. Stephen receives twice as many as Caitlin. Austin receives 4 more than the number that Stephen receives. Total, they receive 539 snaps. How many does each receive? So the hard part is deciding who is the first person you want to define your variable for. And in this problem, we're going to use K for Caitlin, because Stephen refers to Caitlin and then Austin refers to Stephen. So if we start with Caitlin, then we can write an expression for Stephen. So if K is Caitlin, Stephen gets twice as many as that. So if K is Caitlin, Stephen is 2K. Twice Caitlin. And then it says Austin is 4 more than Stephen. So we take what we wrote for Stephen, which is 2K, and then we just add 4 to it. So that is our third let statement for this one. So depending on how many people or items are in the problem, you might have more than 2 let statements. So then for our final equation, that's the hard part. All you have to do is add all of those together. 2K plus 4 equals 539 snaps.